Bismillahirrahmanirrahim. Assalamu alaikum students. I am Sabir Hasnain, your science subject teacher. As we discussed in last videos about the reactions of metal with acid, with water, and with air and oxygen. Later on, in next video, we discussed about the reactivity series, in which we can order all the different elements to their reactions. And now our aim is to discuss the reactivity series and displacement reaction by using the reactivity series. Now the reactivity series and the displacement reaction by using the reactivity series. Reactivity series for metals. Now look at this table. On the left side we have metals which are in order from top to bottom. At the top we have potassium, sodium, calcium, magnesium, aluminium, zinc, and at the bottom we have silver, gold, and platinum. They are all in order. At the top we have the most reactive metal. At the bottom we have the least reactive metal, which is platinum. So let's move towards the second column. In second column, front of the potassium. So reactions with air and oxygen. So this shows that potassium, sodium, calcium, magnesium, aluminium, zinc, and iron, whenever these metals react with air and oxygen, they burn in air. Okay, they burn in air. Let's move downward in order wise. Tin, lead, copper, they whenever they react with air and oxygen, they produce oxides from forms thus on the surface in air. And further, if we move at the bottom, silver, gold, and platinum, there will be no reaction with silver, gold, and platinum with air and oxygen. On the third column, in third column, the reaction of these metals with water. I told you earlier in previous videos, potassium, sodium, calcium, magnesium, all these three, potassium, sodium, and calcium, these three elements reacts vigorously with cold water. And move at the bottom, further move, magnesium, aluminium, zinc, iron, tin, lead, up to lead, they react with steam, and the reactivity series actually decreases from top to bottom. It means magnesium is higher than aluminium, then zinc, then iron, and tin at the bottom. Okay, so magnesium is at the top in the reactivity series, then we will have aluminium. So now if we move further downward, the reaction of metals with water, copper and silver, gold, platinum, they do not react with water. There would be no reaction. That's why no reaction with water. Come at the last column on the most right side, the reaction of dilute acid with metals. Again the same thing, potassium, sodium, and calcium, they react vigorously. In fact, I told you earlier videos, the reaction with acid is faster than as compared to water and oxygen as well. And then magnesium, aluminium, zinc, in order wise, decreasing the reactivity, reacts but decreasing, going downward in the table. And at the bottom, copper, silver, gold, and platinum as well, they do not react again with acids. This is how acid will react with different metals, will react with different kind of materials, oxygen, water, and acids. Now our aim is to discuss the displacement reactions. Displacement reaction is actually the type of a reaction in which one reactant is replaced by another reactant. This kind of reaction is called displacement reaction. It means one thing is displaced from the other one, or you can say displacement or replacement, or you can say they can displaced. So a displacement reaction is also known as replacement reaction. There are two types of replacement or displacement reactions. One, single displacement reaction. Two, double displacement reactions. Look at the figure. From this figure, we can understand the displacement reactions. Consider A, B, C and D. They are different elements. They react chemically. On the left side of the arrow, we call all of them reactants. On the right side, we call all of them the products. When two things reacts on the left side, they produce products on the right side. In the first one, we will observe that when A combines with B, A is some element, B is another element, they produce a new compound, that is AB. It means they combine together, form a new compound. In the next second one, A, B are already combined. It means they are already, when they are combined, and on the right side they are separated. Now come towards the third one. This is actually the single displacement reaction. How? AB is already a compound. If we add some another element, C, look in the figure on the right side, C is actually displaced. B is actually displaced by C. So A and C is a new compound and B becomes separated. Actually, in other words, B is replaced by C. C comes on the place of B. This is called the displacement reaction, in which one element is displaced or replaced by some another element in the compound. Now this is single displacement reaction. Now move towards the fourth one, double displacement reaction. AB is another compound, CD is another compound. Okay, when they react chemically, look, A is combined with D and B comes along with C. It means D comes one way and B comes another way. So two things are displaced. That's why the fourth one, AB plus CD, they are converted into AD plus CB. This is called double displacement reaction. So the example of displacement reaction, keep in mind, in this video we'll only discuss single displacement reaction. In this figure we have an iron nail. We put into the copper sulfate. The reaction takes place slowly, and later on the iron nail becomes red brown in color. This is the chemical reaction. Actually, what is happening there? The iron atoms from the nail passes into the solution, and copper atoms that were in the copper sulfate solution form the layer of red brown solid copper in the nail. Let's discuss this thing through equation. Now, as I told you, single displacement reaction are the reaction in which one reactant is replaced by the another, A, B and C, while B is replaced by the C. In the previous slide, we discussed the iron and copper sulfate. Look at this. Iron is a separate compound. Copper sulfate is iron is an element which is metal. Copper sulfate is a compound. So copper is replaced by the iron. So that's why we get iron sulfate, and at the end we get copper as a separate element, which is another metal. This is how they are displaced in single displacement reactions. So the conclusion, a displacement reaction can only take place when the metal put into the solution is higher in the reactivity series than the other metal in the solution. For example, the above reaction we discussed, if we put zinc, magnesium and tin into the copper sulfate solution, the reaction will occur because the reactivity of zinc, magnesium, and tin is higher than the copper. And if we observe silver gold, and if we put silver gold into the copper sulfate solution, the reaction will not occur because silver gold are less reactive in reactivity series. That's why reaction wouldn't work. The reaction will not occur. So this reaction can be this reaction, I mean the displacement reaction, by we can use this to investigate the reactivity series of different metals.